Alright guys, today we're gonna clarify rules for logarithm, and actually here are the list of the rules. That's about the proofs. So here I'll just prove and probably try to give some examples. But the main purpose here is to prove and show how the rules work. Alright, so that's level is actually a primary GCSE. It's not, because for GCSE you just need to know the rules and need to know how to apply, but for GCSE extended, for especially for A-level stuff and for IB studies, you need to be able to do that. Okay, so pause the video, try to do by your own, try to see like how you can apply this sort of rules to specific examples, and here I started proving. Alright, so let's consider the first property, log A1. Okay, so guys, before you start doing that, make sure you just remember that we have, let's say we have log with the base a of y equals to x, so that you can convert into exponential form to get exponential writing. That's necessary for that properties. And we start doing the first one. Okay, so let's say we don't know that log of any base a of the number 1 it's equal to 0, so we just put some x and try to prove that actually x equals to 0. So we need to prove that x is 0. Okay, so how to prove? Just simply try to use exponential form here and try to raise your a to the power of x. So you'll get a to the power of x equals to 1. So in this case, no matter which the base a, if x is 0, you'll get a to the power 0 is 1. So for any a, so that makes sense. If x 0, this property is proved. Okay, so we proved recently the first one. Okay, so next one, log with the base a of number a is 1. Okay, so let's try to prove and see how it works. So log a of a, let's say it's a known number x. So what we're gonna do, we again apply the exponential form, a to the power of x equals a, from where, because you know how to solve this sort of equations when you have like some bases, they are the same, and that means that x is going to be equal to the power that stays here. So this is 1, so x is 1. So we just proved that the result of that is 1, and we proved the second property. Okay, so let's move next. So this is about log a of the product x times y. So x times y, and this log equal to log ax plus log ay. So how to prove that? How to prove? Okay, so what we're gonna do? All right, I'll do the same. I just simply try to work out using this equality and state that it's correct. So right now we believe this correct, so exponential form should be also correct. And that's why we take the basis a and raise to the power of that. So just by definition, by def, we can say that if, just by def, if we raise a to the power of log with the base a x and plus log with the base a y, we'll have xy product. Okay, so we need to prove that right hand side is going to be xy. Okay, so how to prove that? We just simply need to do the following. Because a to the power of the sum, we just remember the power property. If we have n plus m, the resulting will be a to the power of n times a to the power of n. Okay, so if we apply this property here, we'll get the following: a log ax times a log ay, and the result is going to be xy. All right, so what we're going to do next, if we raise a to the log ax, this is sort of another property, and actually, let me see. Okay, we don't have it here amongst the properties, but we know that actually log a to the power log ax should give you always x. That's by property of the inverse function. So simply you try to get inverse function. Let's say this is an inverse, right? Because a to the power, and here we just put f from x. So by the property of inverse function, we'll get x. So that's by the inverse function. So you can watch probably a separate video about inverse, but this topic is sort of A-level stuff, and that's why you need to use this property. And hence, what we're gonna do, a log ax is x, and in the same manner, a log ay is simply y. And hence, instead of this and this, we'll simply have x times y, which is correct because right hand side is also x times y. So that was based on the property of the inverse function from the function, and that will give you x. Basically, the result of that procedure is x. So we use that property here. Make sure you understand that. If not, just try to search in YouTube how to find like inverse of the inverse function, and you will understand that the result will be x. Here, how we apply that rule to logs. Okay, so that was probably the most difficult. All right, so the same log axy. I just simply state that we're gonna do the same. We'll take a and raise to the power of the difference. And in this case, we'll get that one, and we'll have the difference of logs. And we need to prove that it will be equal to x over y. But look, one more time, a to the power log ax is going to be just simply x, right? And a to the log ay is going to be y. But because of subtraction, we use again the power property of the difference. That means it's going to be an over am, and we'll get the same on the left hand side, we'll get x over y. So that's the same logic as for 3. Okay, so we've done 3 and 4. So we'll move next. Oh, that's much more interesting. Remember, we used it before when I explained logs basics. Okay, so what we're going to do, we need to prove that log axp is simply p log ax. Okay, so simply it means this property tells you that if you have some number x to the power of p and you take in the log with the base a, you simply put the power just in below log and multiply it by the log. Okay, so now my goal is to prove that. So let's say that this equality is correct, and we need to do as normally we do with that. We just simply take a and raise to the power of the resultant y, which stays here on the right hand side. So we simply take, by definition, and take a and raise to the power p times log ax, and that should be equal to x to the power of p. Okay, so perfect. How to prove that? So simply we need to have on the left hand side also x to the power of p. Okay, so what we're gonna do, we just simply need to say that if we swap them p and log ax, like first we put a to the power log ax, we simply use the property of powers, m and to the power of n, which is simply am times n. So if we use that property, we can figure out that a to the power log ax and to the power of p will be, on the right hand side, we need to prove that this is x to the power of p. Okay, so let's simplify a to the log ax. We use the previous property, simply x, and it's going to be x to the power of p. So this is the left-hand side, LHS, of our equation. And that means LHS is also as right-hand side. So we proved that. Okay. So make sure you understand that. So 5.2, another property. Log with the number, so with the basis a to the power of p. Okay, so what we're gonna do, let's try to figure out. So we have a to the power of p and to the power of that. Okay, let's do. So we take simply a to the power of p, and what we're gonna do, we just need to raise to there. That's resultant right hand side. Okay, so we take a to the power of p and raise up to the power 1 over p. So simply when we raise up, we simply multiply by 1 over p times log ab, right? That's what we're going to have. And that should be equal to resultant b. Okay, so p simply will be cancelled. P will be cancelled and will stay with, on the left hand side, we'll stay with LHS a to the power log ab, which is in its turn is simply b, right? And left hand side is b, so it equals to the right hand side now. We proved that. Okay, so we proved actually we proved 5.1, 5.2. Okay, so the last one, look.